Hello, everyone, and welcome. Thank you all for joining us today for this live stream event. My name is Albena, and I'm the Program Manager of the Microsoft Reactor San Francisco. I will be sharing session resources with you in the chat, but before we begin, I would like to quickly review two items with you, our code of conduct and our event guidelines. First, please take a moment to review our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We do encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. This session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I'll be sharing the link in the chat for our YouTube channel, and if you have not been on a live stream through YouTube before, please know that you must create an account on YouTube in order to access and interact in the chat. You can set that up right now, and if you're unable to use the chat but have questions, feel free to reach out to us through the social media or meetup page. Which brings us to today's session, Tech or Treat. We have Renee, Jim, and Sam. I'll be bringing them up right now. Hello, Jim.
Hello, how you doing?
Good. Hello, Sam. Hi, Renee.
Hello, everybody.
Awesome. Hello, everybody. I'm Sam Wronski. I'm a regional cloud advocate here at Microsoft, joined by Renee and Jim. Do you want to introduce yourself, Renee?
Yeah. Hi, I'm Renee. I'm a regional cloud advocate from Sydney, Australia, joining to learn more about Halloween, really.
And your camera's frozen as well, Renee.
Oh, good. That's terrific. Well, we'll work on that. Oh, okay, great. Look, the tabs are still working on being closed, so any minute now, I'm sure I'll come back.
Cool. I'm Jim. I'm a regional cloud advocate in Redmond in Washington State. Not a local American, as you can tell by the accent. I'm been here for the last 3 years. And yes, this is my natural hair.
Mine too.
Very pink. So what we're doing today is building IoT pumpkins. So it is Halloween next Monday, I think, the 28th. Not 28th, 31st. That's how dates work. So Halloween is coming up, and so we wanted to do something to show you how to build a IoT-based pumpkin, so you can do some really fancy lighting or maybe add some extra effects onto your jack-o'-lantern and maybe turn it into a hack-o'-lantern. So that's what we're doing today. We're going to kind of dive into how to get set up, how to work with some of the basics in either Python or .NET or with microbits, and then we will explore more. If you have questions, feel free to ask them. Other than that, I think we'll kind of just jump right into how to set everything up. So where should we start?
Before we do, a question for our audience. Yeah, I know Halloween is not always celebrated in all parts of the world. So I guess a question for our audience is, where in the world are you? And do you celebrate Halloween? And maybe what are some of your Halloween traditions? Because we all have different traditions, don't we? In different parts of the world.
Yeah, it's not super a thing in Australia, but it's kind of becoming a thing. And I'm like, I think this is an okay thing for us to adopt. It just seems like a wholesome community activity. And you get to dress up, which I'm really a fan of, as you can see.
Yeah, a wholesome community activity where you bang on people's doors and demand sweets. And if you don't get them, you will then give them cause trouble.
Yeah, that's true.
Free candy. So where should we start if we're talking about setting things up? I think we're building with Raspberry Pis. Is that right, Jim? We're using
Yep, I'm building with a Raspberry Pi. Well, I guess should we start off by showing off? What have you, Sam? Do you want to show off your pumpkin?
Yeah. Mine is a really bad joke. It's Git fork. What about you, Jim? What have you built?
So I've got mine. Let me just. Oh yeah. Thank you very much. Someone added me. I'm not logged into StreamYard, so I lost control. Let me just adjust my lighting. So this is mine. And if somebody were to walk in front of my pumpkin, for example, and then we get a lovely spooky laugh. So that's what I built.
Yes. I'll show
Awesome.
you
What
mine
about you,
in a
Renee?
second. Apparently mine's chewed through all of the battery. So give me 1 second to change this battery over. Because, yeah, running NeoPixels off the battery, apparently too much. 1 second.
Now,
Into the battery
while
bag.
Renee's doing that, something I've noticed
I
about
made
yours,
something
Sam,
with
is it's a
microbit.
pumpkin.
Yeah.
And mine is a pumpkin.
Yeah. Okay,
Yes.
there we go.
Renee's is
And-
not particularly pumpkin shaped.
No, I think she's using
and
a
I've made
pineapple.
a microbit controller. Well, my pineapple's hat has fallen off. If someone could pop pineapple cam into the show, that's great. Yeah, so this is my so down under in Australia, it's obviously not pumpkin season, and we also don't typically grow the kind of pumpkins that you see for a jack-o'-lantern, except they do appear around Halloween time, which I'm like, where have these come from? How much is the carbon cost on getting these pumpkins here? So I've gone for a pineapple instead. A local, it's coming into spring, summer here, so it's pineapple time. And yeah, I've made pineapple light up with my microbit. This is my microbit remote control, because there's another microbit with the pineapple, and I've got a few different modes. I've got a flickering mode set up, and I've also got rave mode set up. But we'll just have to wait. It is blocking, so I have done this with make code block coding, because yeah, good for all the kids to get involved with. So yeah, that is my rave pineapple.
That's so awesome. Can you tell me a little bit about microbits? So I've never used one. What is it? Oh, pumpkin was too cool. I think we lost Renee.
We did.
Right. Well, should we do a little bit of talking about Raspberry Pi stuff, and then we can bring Renee back in when
she reconnects.
We go.
Put me back in. Hello. Sorry, some technical difficulties apparently. It just fell out of the stream.
Welcome back.
Some pineapple.
Well, Halloween is a time of scary things like no bandwidth.
That's it.
That's what we're all scared of, aren't we?
I am terrified. Cool. So
I think we jump into how do you actually configure these things. So we're using Raspberry Pis for this, or a microbit. Let's talk a little bit about how to actually get those set up. How do you actually set it all up on your computer so you can actually do some development on it? How do you connect to it? How do you get your Visual Studio Code instance to actually get onto it, or just SSH in, whichever one you prefer? Do you want a demo? Should I demo? What's the best for this?
Go for it. You can demo.
Okay, cool. So Jim and I have both been kind of working in parallel to build different things. So we've been, that's why we're discussing this. I'm going to hide that. But so when we're talking about setting up your Raspberry Pi, this is the tool that I use. It's the Raspberry Pi Imager, which allows you to kind of pick an OS and configure your Raspberry Pi's SSD, or SD card rather, to actually run the OS. For my demos, I'm just using the basic Raspberry Pi OS, and then you just choose your storage and select the correct thing. So you'd select your SD card and just click write. I've already done this, so I'm not going to click this anymore. The other thing to take a look at is this gear down here. You can also, I believe, Control-Shift-X will also access this. But this is the advanced options setting, which you can use to actually update and configure your entire thing a little bit more. So in this case, I'm giving it a very spooky host name so that I can connect to it a little bit easier. So the host name is sort of what you can use on your local network to help connect to the device. So giving this a nice, useful name that you'll remember can be a little bit nicer than an IP address. The other thing I'm doing is enabling SSH. which is going to allow me to actually automatically connect over SSH and do work on this Pi without having to swap the SD card back and forth. So I'm doing that, and I'm using a public key for this. If you don't have one, you can just use a password. But if you have a public key, this will make your SSH process really quick because it will automatically authenticate using that key when you attempt to connect to it. And then the other thing I'm doing is setting up my Wi-Fi because we're running this somewhere else. I don't want to connect this to my Bluetooth or to anything wired. So we're running this on a wireless LAN. And so I'm just giving it all of the details to connect. And that's that. Yeah. Hello. Welcome. So yeah, we all got dressed up for Halloween. It's pretty fun. Our job is pretty neat.
Yeah, so I guess a question for Gannett, Ak, what are you dressing up for Halloween? You know, we're dressing up for you, but what are you dressing up for Halloween?
I don't know what I am. I don't know. I just
You're
had a top hat and
Sam.
a coat, so it worked.
Like a little bit steampunk, I'm gonna say. It's kind of the vibe.
It does have the like bronze gears up here, so that I guess that's how it works. And the feather. I guess there's a feather. Cool. So this is how you would set up your Pi initially. There is an additional step if you are intending to develop with .NET, but we're going to skip that, I think, for now, because this is all you should need for Python, if I'm correct. And so this will get you all set up. This will get you everything you need to actually connect. Tonight, you're just dressing up as usual. Do you have any plans to do something cool? Just at work. We are too. Our work is a little weird.
Do other people not dress like this for work?
It's just us, I guess.
It's weird.
Cool. So once you've got all this set up, you can save this and just click write. That will flash your Pi, and then you can just put that SD card into your Pi and plug it in, and everything should be good. If you've set up the Wi-Fi and SSH stuff, it should automatically connect to your Wi-Fi. You should see it on your router, and you should be able to SSH into it using the host name you configured. And so that's actually what I've done in the background here. This spooky thing is already authenticated. I'm already logged into it. We should probably show how to do this, though. So let me disconnect. Better idea. Let's just get rid of this entirely. That'll work. So let's do this and open up just a random code instance. Not a file. There we go. Doing fun things. So this is going to open up Visual Studio Code. What we've been using, I think, for development is the remote Visual Studio Code development tools that allow you to actually access a remote device over SSH or other alternatives like containers and be able to actually edit code on those devices. So this gives you a way to actually connect to your broken code is being used by another process. What if? Oh, all right. This isn't going to work, so we're just going to wait for it to update, I guess. But that's the thing.
If you want to flip to my screen, I can show that off.
Okay, cool, perfect.
So I will just so from Visual Studio Code. Let me just bring up a new Visual Studio Code window. So there is an extension, which is the Remote Development Pack. It's pretty cool. It's a remote.
The top one, I think.
Top one. There we go. It moved as I was typing. It's a Remote Development Pack. This has got a whole stack of extensions to allow you to develop remotely. So if you're using it on Windows, then you can connect to any Windows subsystem for Linux folder. So from VS Code running under Windows, you can connect to any WSL folder. If you're running a container, you can actually open up inside a container, or you can actually remote via SSH. So that means you can connect over SSH to any other device that accepts an SSH connection, but you are running as if you are running on that device. So if I go here and I go connect current window to host, and what did I call mine? I'm connecting as Pi. It's my user at pumpkin control.local. You have to put the .local on the end if it's on your local network. This will then connect. So it's now connected. So VS Code is running, but in my terminal here, I'm running it on my Raspberry Pi. In fact, if I just zip over here, that Raspberry Pi, just there. That's the one I'm running on. And my terminal is on the Pi. I can open a folder on my Pi. So I've got my pumpkin folder, which is already opened another window, hence why I zip back here. But this is on the Pi. So when I develop, I'm coding on the Pi. If I debug this, if I stick breakpoints and run it, it runs on the Pi. It's just the VS Code UI is running on my Mac, which is pretty cool. So one of my favorite extensions. Use it all the time.
It is really cool. Another thing, you connected automatically because you have a RSA key, I think. If you haven't configured that, you'll get asked for a password every time you connect to that device, which is one of the reasons that like having that RSA key set up can be useful. It simplifies that if you're connecting really quickly or often to a device, compared to asking for a password every time you try to establish that connection. But either one will work. So however you want to set that up, it will still work.
Mm-hmm.
All right. What should we do next?
Is your code back? Is it working?
It is. Yeah. So I'm back. And so sort of talking about what we've done here is we've solved this 3 different ways. I've built a .NET solution that can run a pumpkin pie. And Jim has worked on doing something with Python. And then Renee has done something with microbit. And so all 3 of us have like different solutions for how to do this. There isn't necessarily one that's better than the other. It's just sort of however you want to do it. This is sort of intended as a fun way to kind of learn IoT stuff. So however you're looking to learn IoT stuff, grab the one that sounds the most interesting or is most familiar to you, and you can
have the stuff on hand already. If you already have a microbit or you have a Pi, then like just go with that if it's there. If you're like, I did have a Pi sitting around for like a year that I borrowed from a friend who'd had it sitting around for like 3 years and she hadn't used it. So I was like, I was going to give it a go. But then after some necessary updating, the GPIO no longer worked. So that's why I went to the microbit, which I had a pile of sitting over on my desk. So it's just convenient sometimes. Should I show the MakeCode website to show how you can set that up? And would that be good to do now? Yeah.
It's probably kind of the easiest one to set up, especially if you're doing with kids.
Absolutely.
It's probably the easiest one to do. Though I don't know how cat proof it is.
Yeah, look, that is slightly concerning at this time in the pineapple zone. But yes, let's talk through just MakeCode. Just really easy to get involved with microbit on MakeCode. Even if you don't have a microbit yet and you're like, I want to see what it's like before I commit to buying a, I don't know, $25 microbit. So yeah, you can go to MakeCode microbit, makecode.microbit.org, and you can just start by making a new file, which is really easy. So I'm going to call this one my pineapple, for instance. Yeah, that's what we're going to call it. And we can create that. And then it's just, so you've got options here. So I've done all of my code actually with blocks, which was in some ways more difficult because you are limited to the things that you can do with the finite blocks you have. But you can switch to Python, which is much friendlier if you're already a Python developer and you want to have flexibility. But if you do want to get involved with your kids, especially if they're in primary school or elementary school, as you'd say in the States, or maybe even early middle school, you want to, go in, and I go with blocks. It's a great way to get them started. And they have an extension for the NeoPixels that you can just add. And yeah, it's just super easy. And now you're going to have blocks just for the NeoPixel already. So it's already set up and ready to go. And yeah, I've just, firstly, you kind of just want to maybe have some different stuff with the different buttons that you're going to have. So when you start it up, you're going to want to like add your NeoPixels. So I'm going to be putting mine, when we get to the wiring section, I'm going to be putting mine on pin 0. And then you can just go to town with like different options. So we've got a couple of different button options. So I'm going to input, and just on, button A pressed, we're going to have one thing. On button B pressed, we're going to have another thing. And on button C pressed, we could have a third thing. And then you can just put things inside of those. And then, we could actually test these out on the emulator, which is really handy if you like haven't committed to firstly the microbit, or maybe you haven't, got your NeoPixels or your LED strip in the mail yet. If you're waiting for that to be delivered, you could get started with your kids today in the preparation for Halloween, even if you are waiting on a delivery potentially. Super easy to get started. And then, I'm just going to chuck in a couple of different colored options. I've got 16 pin things. So I think this one is actually not about how many pins there is. So I'm going to say 148. I think that's the color range it has. So you could have one for rainbow. I could have one that does. So this one's going to show a variety of colors in the span of this range of colors, which I played around with. I don't quite understand exactly the terminology it's using for that. It's assigned one color to everything in that, range of bytes. You could have some more different colors using just the set color, really easy. So maybe I want one red one, and then maybe I want one that flashes 10 times. So I'm just going to set up, a little loop with repeat 4 times. I'm going to turn the light on, and then I'm going to change it to 10, and then going to pause for a second, or like, let's say a millisecond. Where is our pausing ones? Let me remember. There we go. Pause for a second, and then you're going to have let's turn the lights to black for a second, and then we're going to pause again. And then you'll have a bunch of different stuff, and super easy for kids to just like do something and play with a bunch of options there. So in a second, we should be able to, we're going to update that to 16. We should be able to do something on our little emulator, which is really convenient. I think it's running. So we have the flashing one, we have that one, and then I can do A and B on my keyboard. Wait, is this invisible button? And then we have the rainbow one. So like super easy for your kids to get set up. I'll show you through like a little bit later the one that I've actually got set up, which has got a rainbow thing going on. Not a rainbow thing. It does have a rainbow flashing sequence, but it's got a radio thing going on, which is how I'm actually communicating with it. I'm using make code multi for that. So I've actually got this code over here, but I'll talk through that in a little bit, where you have, one microbit, music being my remote controller. And I've got another one over here that has all of the different stuff I've got set up there. But I'm going to pass back to you both to talk about more about, I guess, are we talking wiring next, or?
We probably should talk about wiring. It is different for .NET versus Python. I think Python's wiring is slightly easier. There's a few things you have to change for .NET, because .NET is using SPI. But I think we can talk a little bit about that. I think both of us are using external power supplies as well for stuff. Or Jim's not, and I am. So you're lucky.
They're just plugging straight in.
Cool. So I guess mine's complicated and annoying. I don't think any of them require. None of these setups, I don't think, require soldering. I don't know about the microbit, but
my NeoPixel rings are actually soldered. That I happen to have already soldered for a Kookaberry, so they're connected to a JST connector already. So I had to do some daisy chaining to get them onto the thing that needed to go on the microbit. So yes, maybe it requires soldering if you have got a ring like me and it just came as the ring in the mail.
Yeah, I think so. For me, it's screws. This is going to not move, but it's got a series of screws to connect the power supply, and then just some jumper wires connecting everything together, so that it actually works. But there is no soldering required, so you don't need any extra tools other than the IoT hardware, and then maybe a few jumper wires just to connect things really quickly. But yeah, I think that's it. Jim, do you want to talk a little bit about like the intro, how to wire things, and then I can add on the extra bits that I need?
So I cheated with mine, so I'm not doing any wiring. So let me just get my screen. I can't get my screen. Someone add my screen. StreamYard logged me out. There we go. Thank you. So I'm actually using a thing called a blinked. Blinked. Yes. It has this silly name. So rather than use a whole pixel strip and actually faff around with wiring, I'm using a thing called Blinks, made by a British company called Pimoroni. And it's these LEDs here. These are multicolored LEDs. These are the NeoPixels. So this is exactly the same hardware that Renee, you're using in the Circle, but these come on a board that mounts to a Raspberry Pi. And actually, if I zip to my camera, let's just zoom in a bit more. I've taken mine out of my pumpkin for this. If I zoom in, what I've got a Raspberry Pi in here in a case for protection. I've got this hat on it for a distance sensor, which we'll talk about later. But this is my blinked on top. So this is a series of 8 of these LEDs. And I literally just, as you can see there, they slide onto GPIO pins. So no muss, no fuss, no wiring, all in one little solution that does everything for me because I want it to be easy.
Okay. My solution's not easy. Where to start? So first off, yours is very small and compact, and mine is 4 meters long and it does this.
Yeah, I can't wear mine.
So that's a thing. And then the other thing is that's making it very hard to see. But there's a whole bunch of wires going on here to make this work. Doesn't really matter how it's working. In our GitHub repo, we do have it documented how the wiring is done. But this turns them off. But this is an external power supply, dropping things. And this is actually what's providing the power for NeoPixels. While a Raspberry Pi does have the ability to output power, it will only run a couple LEDs before you'll do things. And even then, I'm not sure I would do that too often. Jim, you might know more about this than I do, but I don't think that's ever a great idea. It might work, but it might not be a good long-term solution.
Yeah, if it draws too much power, it can eventually burn out your Pi. And what's great about things like the blinked I've got here with the 8 pixels is they're designed to run off the power supplies. They've been tested. They will run. And you can buy a thing called a unicorn hat, which has got, I think it's like 5x8. But those ones where they're specifically designed and tested, they will draw as much power as needed, but will not draw enough that can damage your Pi. Whereas if you're putting up just a whole load of strips on, a whole of these NeoPixel strips, you're doing like 5 meters of it, the power draw can actually burn out your Pi. So, for 1 or 2, it's kind of fine to power it from the Pi, but really, you want it when you're getting long strips. I mean, all my lights behind me here, for example, these are all one long strip. For this much, you've got to have that external power supply. Otherwise, your Pi will just burn out. And seeing as how these things are as rare as anything at the moment, if you want to get hold of a brand new Pi, it's going to cost you an absolute fortune. But when you have to buy off a scalper, you don't really want to burn yours out.
Yeah, I the thing is I've screwed this up before and had too much power draw, and it doesn't always damage your Pi necessarily, but it does do weird things. So like lights might not turn on or might turn on to the wrong color or do other weird things that you can't figure out. And it can be really hard to figure that all of that out. The external power supply works. The trick is just making sure you have the right thing. Was before the show was talking a little bit about how I had burned out a series of LEDs because I'd used the wrong power strip because it looked like the right one. So I would keep that in mind, is just make sure that you're reading the specs. If you aren't using something that's a little bit more done for you out of the box, like what Jim has, just make sure you're getting the specs right. Lots of companies will list what it is, like Adafruit and things have power supplies ready, designed for things like NeoPixels that you can just pick up if you want to use that. But yeah, that's that. I've pulled the entire solution apart, so this is fun. All of you have much easier solutions than mine.
Yeah, mine is super, super easy, apart from it's really long. But I'm actually just going to share my screen again because, yeah, I've got up. Well, firstly, I'll show you the one that I'm using, which is this NeoPixel ring from Core Electronics. Yeah, they just come as the ring with no wires attached, and you do need to solder onto the back of them. I guess you could. No, I think soldering is really the way to go with these ones. But it's not too difficult to get that right. You do need to make sure, just make sure you know which wires are going on to where, and then you're going to need to follow that chain all the way down. Normally, if you've not, soldered your thing to a really specific cable that fits into a different piece of technology, you don't have to have this thing that I've got going on. So you might have something that looks more like this. And I actually started out with the Glow-Bit rainbow that a friend gifted to me a couple of years ago. And then I was like, oh, these are so cool, so easy. I'm actually going to buy a bunch to do, my little side hustle. I have a bunch of stuff that I do with kids. And if you're going to do something with kids and you're like, not sure if they really like coding yet, I can tell you the best way to start is with flashing lights and flashing rainbow lights. So getting a bunch of these getting that started. So, but with this picture, you can actually see what the wiring is like for the microbit. So that's why I've got it up. And you can see that, so all I've got is I've connected mine to some alligator clips eventually through my long daisy chain because I just want to get the 3 pins that are data, 3 volts, and ground so I can connect them to my microbit. You can see the color matching there. So you do want the data on one of the pins. That's what we've set in our code here is not that code. This code is that I've got it on pin 0 here. You could have multiple ones of these potentially, but that's probably not going to work because we're talking about voltage and you can only have a fixed amount of voltage coming out of your microbit, which is 3 volts as is written on them. So got that. And then you just want to get your ground and your 3 volt connection as well to the parts written on the microbit as well. So it's super easy to plug in, just clip on, and then you're ready to go with the code and just run the code. So I think I've got the easiest one of them all, just a couple of wires. So would highly recommend for some kids. Also, I don't think it's an issue. I think the microbit kind of caps out. So it caps out at 3 volts. And it just means that your NeoPixel ring doesn't glow as much. And you do, if you try to run all of the lights on the maximum color, which is white, so all of the red, all the green, all the blue at once, you kind of just won't get there. It'll be like slightly yellow if you try and do it all maximum brightness. But that's it. If you have this many, the glow ring, that many pixels. So you can still get a lot of the way just with the microbit, no external power supply required. So it's super easy to go.
Just to clarify some naming here. So we've all been talking about neopixels. So what a neopixel is actually a term from a company called Adafruit. They use this name, but it's a WS2812B multicolored LED. So you'll see them called neopixels, but also WS, I think it's 2812 or 2182. It's got 2s, 8s, 1s, and 2s in it.
2812B is correct.
2812B.
It's in my code. So
cool. And so these are 3 color LEDs. So actually inside them, they've got a red, a green, and a blue. I think they've got white as well. Mixed. I think they've got 4 in there.
Some of them have that.
But they are controlled. So the reason you need 3 cables is because you need the power. So you have your red and black cables there, which are providing your voltage. But you have a data cable, and that actually is used to program each LED. So each LED is individually addressable. So you say I want a 0 to have an RGB value of whatever to set the red, the green, the blue, and then I want 1 to have a different value, and so on and so on and so on. But what's cool about them is they are individually addressable from 0. So the very first one on the wire is 0. And so if you want to add more, if you've got like the strip, the sound that you've got, if you want to add more, you just keep plugging more in. So if you've got a strip of 100, that's 0 to 99, you can just literally connect another 100 on the end, and it will work. That'll just be 100 to 199. And so that's kind of why there's 3 wires in there. Yeah, it's not like an LED where you just send one signal to it to light it up. You actually can program it.
Kind of expanding on that, most of the strips that you can buy actually have connectors on the end. Like the strip that I have, it just has another compatible adapter at the end. So if I had another strip, I could just plug it in, and then you just need to tell your code how many actual LEDs there are. And usually they're pretty standardized densities of LEDs per length. So you can kind of use that to figure out how many LEDs are in your strip, and then use that to define your effects. So,
and another thing I think we should mention here is the inside of pineapples and the inside of pumpkins all have one thing in common. They are wet. And what does not mix with electricity? Water. So
Pineapple juice.
Pineapple juice does not mix well with electricity. Yes. So what I do is my trusty Ziploc bag. So if I get my screen up, so someone can just share my screen. I will literally demonstrate. Yeah, sorry, I can't add my screen. Someone can just add me.
Oh, yep.
Normally, every time I go to stream, I'm immediately logged in, but not this time.
Pineapple,
so, yeah.
Your pumpkin cam? Yeah, there you go.
There we go. So literally, it's as high tech as that. I put it in a Ziploc bag. The advantage of these Ziploc ones is you can then seal up as much as possible, especially if it's going outside. I'm going to sit this on your front porch. You want to have it waterproof as possible. We do that, and that way the electronics in here. Let me just zoom out on my cam. Come on, let's go to ultra wide. Why is this thing not going away? Come on. Oh well. But yeah, so it's now still in this bag. I can then put the whole bag into the pumpkin, and that keeps it all waterproof. I want a top tip as well, actually, a top tip for carving. There's a hole at the back for your wires. So if you're gonna have the whole thing self-contained, if you're gonna have it all battery powered, so Renee, I don't know if yours is just powered by a battery. If it's all battery powered, then that can just live in the bag inside the pumpkin. But if you've got any kind of external power, like Sam, you're saying external power, the wires have got to go somewhere. So you can carve a hole in the back to put it in.
Yes, I've actually just got my light inside it, which is also in a bag. I've got a two-bag system going on here. I'll add my pineapple cam to the stream. There we go. There we go. I've popped us. I'm not very. There we go. Here we go. Pineapple cam. Yeah, has got a battery in a bag. It wasn't a bag until I switched it out. But yeah, I've just actually got the NeoPixel ring inside of there. I just made a little hole and a little bit of a crack actually to just slide the ring in sideways, and then it just sits in there alone because it turns out pineapples are quite a bit smaller than pumpkins. So you couldn't really put as much inside as you might with the pumpkin. But yeah, it can just hang out behind also because I have all that wiring because of the daisy changing of stuff. But otherwise, possibly you could affix it to the top of your pineapple and just have it sit inside on the top, and then it wouldn't be in view because it was also my first time carving a pineapple or pumpkin. I haven't done either of these. So yeah, I kind of cut a bit too low, and the structural integrity of the pineapple may have been damaged somewhat. It's a bit squishable now, but yeah, there wasn't a lot of room to hide a bunch of electronics in my pineapple by the end.
You should have made a scary laugh as you're doing that, like whoa ha ha, as you pushing the pineapple up.
Yeah, excellent. Go. Yeah.
So a top tip, actually, Sam shared this top tip, but I also did exactly the same thing. Is when you put these lights, because they're actually very intense lights, when you put these inside a pineapple or in a pumpkin, you can see the individual lights potentially. So if you want it to have that kind of glow effect, just some baking parchment, tissue paper, anything like that that's opaque, you put that in front of the lights and the whole thing glows rather than seeing the individual lights, and also it hides the wires as well. So good tip, that one.
Yeah, and it'll also hide that hole that you're carving in the back. Otherwise you can actually see through that. So if you are covering it up with tissue paper, you'll get this really nice diffused effect. You can even add some texture that way by like crinkling the paper or whatever, and you'll get some like cracked glass or flame type textures. You can use that to kind of remix whatever you're doing. As far as waterproofing and bags, I don't put my pie into the pumpkin. I just bought a waterproof LED strip and just use the waterproof LED part to prevent anything from happening there. That does mean that I can't cut this. So that's why I have a 4 meter long strip. But it is an option, and they do sell shorter lengths that are like that. And they're just sealed with a plastic silicone thing. Then you can use that to prevent anything from actually getting on your electronics and causing a short or doing other things. Especially with your pie itself, the liquids and stuff inside of your pumpkin is probably not great to get on that. So the bag is a good idea. Should we talk about how to actually do this now?
Yeah.
actually dive into how to write a program for this, and maybe look at whatever. I think Renee, you kind of covered.
Yeah, I covered my getting started one. I will talk about my radio one in a little bit. Do you want me to take over now, and I can talk about radio and microbit?
Sure. I think yeah, we should do yours and Jim's, and then I think my setup. I think maybe we can just showcase on the GitHub repo. We do have a GitHub repo for this project, so if you want to borrow some of our effects, that's where you can go to get them. Yeah.
Okay. Yeah, cool. Well, I gave you a brief rundown of what I had set up just to get you started with being connected to things. I did forget to mention how to actually get it onto your microbit. So you can see here that I can pair a device. So I can just go in here, and I've got one plugged in, so I could pair that and connect it up. And yeah, that way I can just download straight onto there. If yours isn't quite the latest version, you might need to either update your firmware, or you can just download the file just to your computer. And then you can just drag the hex file onto your microbit. But yeah, let's talk about the code here. So I've got, so running on my on Pineapple Cam is this code, in fact. So you could get started just with the demo I showed earlier, and you could just run that as we saw in this demo here, and just have that put into your pumpkin with your little microbit hanging out the back, and you could just press the buttons to have different things run. But you might want to not be standing and have to go to your pumpkin/pineapple, wherever that's placed, so you can just control it remotely. So I've actually got a radio system set up to do that. So I've got, when we start up, I've got both pieces of code up here, because you can go into makecode.microbit multi. So you can have two things. So you can have both your code for your transmitter and your receiver side by side. Just makes it way easier to test it out. And you can connect multiple microbits through this. So I could pair the one that goes in the pineapple and one that is the receiver, and then I can test them out without having to, unplug, replug, etc. Really convenient. So yeah, all I've got going is, for the different button presses, instead of like I had before, where I actually just control the NeoPixels directly. I'm having them transmit a message. And I'm also just showing something on the screen so I know which buttons I've pressed. I'm saying on, flicker, off, and what I call rave mode for my pineapple. And then, yeah, I just send that. I've added this microbit to group 1. If you had multiple of these, if you were doing this in a classroom at a school, you don't want everyone to be on the same channel in the same group. So you get each student to put themselves in a different group. So yeah, that's my hot tip because I've seen things go awry. So yeah, we've got that set up. So I'm just going to move to my main part of my code, which is a bit chaotic, but it's really much like what we've had going on before. I'm just going to move this actually out of the way so we can see the simplicity of what we've got going on. We've got on, so when we receive a string, so we've said, okay, cool, we're adding ourselves to the group, we're setting up our NeoPixel when they start up the code, and then, yeah, we can just get our radio message received and just chuck an if statement in there to say, okay, we're just looking for the different words that we know are coming our way. So, yeah, for one of them, I've just set it to orange, that's the on one. For the, I've got an off one, which is when they press A and B. And then I've got my 2 other modes, which are flicker and rave. I should note that over here in this code, I've used one of the gestures, which is screen down. So you can do if shaken, if you do, if it's falling, if the screen's up, etc. Yeah, you can just use those using the accelerometer to trigger different things. So you have many more options than just the A and B button to trigger something. So I've got, when I put the screen down, it's going to trigger rave mode. Yeah, but a little bit more complicated code because I am working in blocks. It was a little bit trickier if I just done it in Python, but I wanted it to be able to be done by everyone like 8-year-olds as well. So working in blocks, and I've just got 2 different parts that are just setting the colors because we can individually address each one of these things, or we can just, mostly if we're working in blocks, we're just addressing the whole strip and setting the color. So I've done above, you can set orange, but you can also set a hue saturation value kind of thing going on here with a different luminosity. So I just wanted to flicker. So I wanted to go from just, varying the luminosity. So I've used 2 loops to loop so I can jump by 5 between the values of 30 and 60, going up to 60 and then coming back down. So yeah, and just pausing for 100 milliseconds on each of those. So not too hard to get that going. It would be a little bit easier if I had the options to change, vary. I didn't have to go from 0. If I was using just actual Python, I could do for range, 20, 30 to 60 without having to do that workaround. So the maths is a little trickier, which is annoying if you're working with smaller kids, but not insurmountable. But yeah, finally, I've got my other one, which is just my rainbow rave mode, where I just go through all of the colors available, show color, pause for 100 milliseconds, and go. And so I've just downloaded that onto the one that is on my pineapple, and now I can control it from the one that is on my desk, which also can run on battery power, but I stole the battery to put it back in the pineapple. So yeah, I can just activate rave mode, which you can't see anymore because I've moved my pineapple too close. But there we go. Pineapple is now raving. So yeah, it's super easy to get something running with radio, and yeah, using MakeCode multi. So yeah, that's really the whole pineapple setup. That it's as easy as that. If you do want to work in Python, you can just toggle to the Python thing, and you could make your code look much prettier than this, because I obviously would have used a loop and a list, but making the list would have taken just as many lines of blocks as it did to do it without that. So I made it as easy as possible. So I don't know, an 8-year-old could easily do it. So yeah, that is my whole pineapple project.
So cool.
Yeah.
I haven't done block programming in a long time.
Yeah.
And it's so much easier than it used to be.
Yeah, it's super easy. And look, honestly, sometimes if I'm like, oh, I forgot what the library is called, I just go into the blocks and then I look at the generated Python code. I'm like, yes, that is the nomenclature for this library, and NeoPixel HSL, terrific. And it's kind of just like documentation. So super easy to get started with. But yeah, how has yours worked, Jim? I'm going to put your screen into the mix.
Okay, so mine is all done in Python. So one thing with the Raspberry Pis is there's so much hardware available that you can get kits like this Blinks, and most of them have Python libraries. So it kind of made sense for me to do it all in Python. So the first part, got a whole lot of asynchronous code in here that does a few different things, but the first part I've got is this loop that sits there and runs a flickering flame inside it. And if I actually go to the code for that, what this does, this uses the 8 pixels in the blinked, and it sets an initial value for those, and then it does a slight random adjustment to the colors to make it look like it's flickering. So if I just run this to show you what I mean, 3, 5. So if you go here, and you can see we've got these lights flickering away in there. And the way that works is I choose initial RGB value. So this is the base color that I'm using as my flame color. I then clear out my pixel strip. So it's 8 pixels I can reset. I then go through each of the pixels. So it's from range 8, that's from 0 to 7. I pick a random flicker value for the pixel and use that as an adjustment to the red, green, and blue. So we get a slight color adjustment to each one. Then I set that pixel with a random brightness. And then I update that. So all 8 pixels get updated at once with this color. And each pixel will be slightly different variations around my base color. And then I sleep for a random period of time. So kind of it flickers kind of different pulses, different ways. And that gives us really nice effect where the lights are changing color and each one changes. Think about if you're staring at a normal fire, it'll get brighter and dimmer in different areas at different speeds. And like get brighter quicker and then dim quick and then bright slowly and dim slowly. That's kind of what we're getting here by having that random adjustment to the color and the random adjustment to the pause in between. And that gives me my lovely color effect. But I want more than this. I want to be able to, when someone walks up to the pumpkin, I want it to pick up and scare them. Yeah, this is going to be going outside my front door. So when someone walks up to grab some candy, because I'm not going to be there dishing out sweets to kids. I'm going to be trick or treating with my family. So when this is sitting there, when people approach, I want it to laugh at them. So what I've got in there is inside all this. You probably see it here. This here is a distance sensor. So this uses a laser rangefinder, pumpkins with laser beams. So it fires a laser beam out and will measure the distance based off the laser that comes back. And this is a Grove time of flight sensor made by a company called Seed Studios, who do a lot of really cool hardware. And it plugs onto a mounting board. So I put a mounting board on the Pi, and then I just connect this sensor in via a cable. And same with the Blinks, a lot of Python libraries for it, which is pretty cool. So what I'm doing inside my code is I've got a second asynchronous loop running that waits for a distance measurement of less than 1,000 millimeters. So 1 meter. If somebody gets within a meter, it picks this up. That's 3 and a bit feet for Americans. So the way this works is it'll measure the sensor. So what I do is I'm constantly measuring the distance from the sensor and then sleeping for 5 seconds. So if I just start this up, you will see it measures it. That's the maximum distance, 8 meters. So it measures it, and every 5 seconds, I measure a value. And then in that 5-second window, if the distance is less than a meter, it picks it up, and then it starts checking quicker. It'll actually check 3 times with 1 second waits to make sure that we're within that 1 meter window for a period of 3 seconds. And that's what triggers the laughter. The reason I'm doing it like this is I don't want like a leaf to fall down in front of it and it starts going off, or sometimes it'll pick up, you might suddenly get a low value because the laser beam bounces off moisture in the air. So I've got to put this, there's a bit of smarts in there to say, I've got to have my distance less than a meter for 3 seconds before I do it. So that sits there, chugs away. And then if it does that, if we actually get something for 3 seconds that is closer than 1 meter, it kicks off an audio player. So I've got a WAV file here, which I just downloaded off the internet from a free WAV file or free MP3 site, free MP3 site that advertises a whole of free sound effects. So I just downloaded that, converted it to a WAV file, and then I'm using a library called PyAudio, which is a Python audio library. Name kind of gives it away. And then once I get this detection that something's within a meter, it'll then load this audio file from disk, set up an audio stream, and just push data to it. It's kind of a lot of code for doing it. There doesn't seem to be a simple play this file method with PyAudio that I found. So you have to open an audio stream and then push audio to the stream in chunks, which is what I'm doing. So you just keep writing it. All the way you got data to write, you write the audio stream and it plays that audio. And then when I've finished, I wait 60 seconds because I don't want someone to walk up, have it laugh at them, and then laugh again, and laugh again, and laugh again, and laugh again, and laugh again. You want to have that gap. So it gives time for someone to come up, hear the witch's cackle, grab some candy, and go before the next person comes up and gets laughed at. So that way, if I put my hand in front of it here, so I'm just waving my hand in front, it laughs. But now if I do it again, nothing's going to happen. It's not going to do it for another minute. So the child has just been laughed at by the witch and got their candy, will not get laughed at again. So that's my setup. You see, we've just got the 3 distance measurements and it won't start spitting out distance for the remaining 60 seconds. So that's my setup, all done in Python. All using async IO so I can have the background processing of the distance sensor whilst my flame is flickering away.
I love that. I'm super. I want one for my pineapple now. Like, does it run on I2C protocol or what's the go?
The
or
audio.
Do you
mean?
No, the proximity sensor.
Oh, the proximity sensor. Yeah, it's I2C. So it's part of a Grove kit. So it actually comes. I'll show you. Just dismantle my pineapple.
The pumpkin. I keep saying pumpkin, you keep saying pineapple. It's great.
It's too confusing, all these different things. Let me just...
Produce.
Shush. So if I get my camera up, here we go. Let's get this camera up. So Seed Studios make this whole series of Grove sensors. Let's zoom in a bit. There we go. And so here's the Grove sensor. It comes on a standard cable. That's the sensor there. Comes on a standard cable that connects to this hat that's connected to the Raspberry Pi. So this is connected over I2C, but it's got a whole ecosystem around it. I can get a hold of other sensors I can put on there, on that hat, and just access using Python code. But yeah, you can just buy these sensors that are available over I2C. And then in theory, you should be able to connect those up to a microbit and add that detection. No. And then definitely for the speaker, I'm just using a USB speaker. So it's just
that's great. Yeah, I guess with the microbit, you can, if you've got the microbit version 2, it has an inbuilt speaker. So I'm like, this could be really great for doing that. But if you don't have the V2, you can wire up headphones or a speaker to, just like I did for the NeoPixels, you can do that, the same thing, to attach a regular speaker, just clipping it to the 3.5mm audio, which is really cool for showing your kids how how those plugs actually work, which is really exciting. And I should have noted that you can actually, there's a bunch of music libraries in the make code blocks or in the Python libraries as well that you could just play, whether you want to trigger that just with your remote or if you want to trigger it with a proximity sensor like Jim.
Play some spooky music when someone gets a bit close. So yeah, that's my setup. Not too much Python code. It's 30 lines in my main function, and then 35 my audio file, 35 for the distance sensor, and 30 for the flame. So it's not much code, but gives a nice, cool effect.
I think that's the exciting thing about like embedded systems and IoT is like each individual thing isn't actually that complicated, and if you can just write a little bit of code, you can integrate them in a really cool way. Yes,
and what's really cool about things like the whole Raspberry Pi ecosystem is there's all these libraries built to do this stuff for you. So to make my lights work, I call clear to reset my blinked. I call set pixel to set the colors, and then I call show. That's all I need to make it work. To play audio, I just run. There's a bit more code, but I just tell it load the file and just write it into an audio stream. For my distance sensor, you call wait ready, and that tells it to send the laser beam and get the results, and then you call get distance. There's good libraries there for a lot of this hardware, which makes it, I don't want to say easy because I hate calling things easy, but it certainly reduces the amount of work you have to do to build these solutions.
It's accessible to kids as well. Like maybe you get started with the microbit when you're under 11, and then you can move on as you develop those skills and understanding of how the hardware works. You can move on into using the Pi, which has a bit more code and doesn't have the blocks, etc. But you have that understanding of the infinite loop that keeps running and how those processes are all coming together.
Yeah, I mean, I wrote this with my 9-year-old. Obviously, she doesn't understand all the code of it, but just the concepts of here's the flame. We set these colors. It looks this color. Now we add random changes. It does this color. And she just grew up the concept straight away. So we were together just mucking about with the different color values to kind of make it look different.
Yeah, and it's really easy for them to pick it up because they can see that thing in real life, showing them different colors. Like, oh, it's a sequence. It goes in order. Oh, if I add a loop, it does this. Oh, if I add an if statement, it does this because I press the button and that triggers this condition or that condition, but not both. So really great way to get kids involved with technology at Halloween time, which I think it's all about the children. It's my understanding.
Yes.
And us wearing our fun costumes.
I do think we are a little bit over time right now. I do quickly want to call out everything that we're showing here, or most of what we're showing here, is on a GitHub repo. So if you want to try this out or look at some of our other demos that we've put together for both .NET and for Python, we have that code available for you, as well as things like wiring guides if you don't have something that's pre-built as a solution and want to just use your existing NeoPixel strip and a Raspberry Pi that you have sitting around and you want to figure out how to use that. That is here. Oh, sorry. I think Jim was pulling it up, but all of this stuff is here. We have wiring diagrams walking through how to get your Pi set up for both Python and for C#. We also have all the Python and C# examples covering different things from how to light up a single pixel using a very small amount of code to the distance sensor sample that Jim was showing. We also have similar things for .NET. There are different examples, like going through and looking at an image and using that image to render out a different effect on your LEDs. So lots of different things you can do and kind of explore if you're interested. So I think that's it. We also have called out a survey, which is sort of our way of telling if this is a useful thing for anybody, if this is something that people want to see more of. So if you like us dressing up and doing weird thematic pumpkin tech, let us know, because then we can do more of this. And I think we would all like to. So let us know. Have I missed anything?
I've just dropped in the chat the links to the code that I showed on MakeCode today, so you can just have that code. If you're like, no, my kid's 6 and she's not really ready to do all of the for loops and if statements herself, she can just go in and change the colors, though. It's a great way to get started by editing some code. So please have my code.
Awesome. And I think that's it. So thank you, everybody, for watching. Hopefully this is useful. And if you make anything with this, we would love to see it. So call us out. We've dropped our Twitter handles into our names here. So send us a message and say what you made. And yeah, let us know. Other than that, thanks, everyone. And
Happy Halloween.
Exactly. Yes.
Yeah. Thanks, everyone. Happy Halloween.
Yeah. Bye.